Hi, this is Fireman, the most amazing physics and math teacher you will be in the universe. In this video, I'm going to talk about important points and mindsets you should have when you study physics, which a lot of students find difficult, so that you can score best marks in physics. Now, I'm not going to talk about all these obvious things like work hard, do exercises, and these craps, but give you more specific points you should bear in mind to be successful in scoring marks in physics. And after this video, since it's exam season, so I'm going to be uploading GCSE, MYP, IB, SAT, and AP Physics contents and so on, which I specialize on. If you're one of those students, then please subscribe and you'll get exactly what you need. So let's get started. A lot of you will find physics difficult because simply you do not understand. Now, when you study physics, you've got to be very careful to find out which parts you have to understand and which parts you have to accept without any questions. Now, a lot of physics teachers must have told you guys that physics is a very logical subject. Well, my answer is actually no, like most of you guys actually feel. Physics is actually a very unlogical subject. Well, I have to use the word illogical, but the word illogical sounds very unlogical to me. But anyway, because in the very depth core of any explanation of physics, there's something called laws, principles, and definitions. Well, you must have heard of Newton's laws, and you guys were probably freaked out just to hear his name. These laws do not actually make sense. For example, Newton's third law. If A applies force to B, B applies force to A in equal but opposite direction. So that would mean if I was to push the wall will push me back in equal but opposite direction. I mean, is the wall a ghost? Well, is there a physical explanation of how this actually works? Well, even Newton himself doesn't actually know how it actually works, so he stated it and died without any explanations. But the observations around the world and universe always worked this way, so it must be true. Now, at this point, a lot of you guys will not like what I've just said, and you all have every reasons and rights to feel so. And this is the critical point why we cannot proceed any further in physics. The students who are good in physics will accept these laws without any explanations and will try to apply in situations to score marks. The students who are not good at physics would not proceed any further from this point because these laws sounds like BSs. So why should you use these BSs to explain something, because these BSs themselves do not have explanations? And guess what? Such arguments are arguments made by Einstein, and he makes up his own laws and tries to see physics in a different way called quantum physics. Now, I'm not going to explain what quantum physics is, but the point is, criticizing the laws in physics is not a wrong thing, because even Einstein did so. But there's a more important thing. You're not Einstein, and all we need to do is to get good marks and go to good universities and make lots of money and move on. Then will you keep questioning these laws? Or will you accept them and try to apply them to get best marks? But once you accept these laws, your life will become a hell lot easier. And applying these laws in a logical way is the way to get you scoring marks in physics. You're not going to get marks by questioning these laws, but this does not mean when you study physics you shouldn't question. Now, asking a lot of questions in physics is the way to getting better in physics and get best marks, because everything in physics is actually logical apart from these laws. But my point is, you've got to know which parts you have to question and which parts you have to accept. Now, throughout the videos I'm uploading, I'll be putting these red boxes on these unlogical things that you should not question. But apart from them, everything should be questioned, and throughout the process, you get better in physics. So, knowing which parts to question and accept is the critical thing in physics. So, the first point you should always bear in mind to score best marks in physics is know where to question and accept. Do not try to understand the laws, because you can't, but try to apply them. Okay? And throughout the videos I'm uploading, you'll see a lot of examples of how you're going about doing so. And the second important thing you should always bear in mind when you study physics is that there's no such a thing as equations or formulas, but these are rather called definitions. Well, from time to time, I'll use the words such as equations for referring, but this is actually very dangerous. For example, a lot of you guys perhaps heard of F equals ma, which is actually Newton's second law. Um, and you guys would perhaps think Newton's second law is an equation where there's three variables. So if the question gives you numerical values for two variables, and you can find your one unknown variable, and you get all your calculations right. But you're not going to go far with such notion for long answer type of questions. In this, what I should be called definition rather than equation or formulas, there's more saying than that. It suggests about the relationship between force and acceleration. So let me elaborate this. So for example, you have an object that is on the ground and it was stationary, so it's not moving. Then you pushed it, so that means you applied force to it. And obviously it's going to be starting to move, right? So as it moved, then it must have gained a certain amount of speed or velocity. And you can see an object that has been given a force would mean that it will have experienced amount of change in velocity over a certain amount of time, and that would mean by the definition of what acceleration is, it would have received a non-zero acceleration, because acceleration is defined as change in velocity over change in time. So that means an object that would have received force would mean that it would have accelerated. And the other way of saying it is that when you saw an object that is accelerating, it means it would have received force. So this is kind of approach you should take whenever you see describe and explain long answer type of questions. So when you see a question, do not just try to pick out the numbers in the question and try to plug them into formulas, but try to interpret these definitions in a more logical way, like I've done here. But having said that, you first will have to accept these laws rather than that it should be called formulas. And that's the first point I mentioned. And the third important point you should bear in mind to score best marks in physics is in any branch of physics you learn or solve questions on, physics explanation always involves these three steps. So you'll be given a certain situation and you have to apply these laws, principles, and definitions to give a logical explanation. Now, like I said earlier, physics is actually not a logical subject, as these laws or principles, definitions, these do not make sense. But ironically, when you do any physics explanations, your explanations always has to be backed up by these laws to describe situations logically. You're never going about doing your physics by your own common sense or intuitions. So, for example, you may think a heavier mass would fall faster than a smaller mass if you were to drop at the same time. But if you were to do it properly, you will actually see that they actually drop at the same time, given there's actually no air resistance. There's no law in physics that suggests that mass is proportional to speed or velocity. There's law in physics that suggests that mass is proportional to weight, which is actually given as W equals mg, so that higher mass would mean higher weight. But there's no law in physics that would say higher weight, which is actually newtons, would be higher speed, because speed is given as meter per second and weight is given as newtons. And these two quantities are different quantities. So do not go on about doing physics by your own intuition or common sense. You always have to be backed up by these laws. And again, you see a lot of examples through my uploading videos how this is actually done. Now, fourth important point you should bear in mind is that everything in physics is mechanics. Now, unlike other subjects like biology, you cannot learn physics in random orders, whereas in biology you could perhaps learn about plants and humans' organs or in different order. Everything in physics is fundamentally developed by this topic called mechanics, which involves topics like distance, speed, acceleration, Newton's laws, energy, and momentum. So this means you cannot fully understand other modules like electricity or waves or thermophysics if you've not fully mastered mechanics. So this is why when I teach, I spend huge amount of time mastering this topic before I move on to other topics. And a lot of time on videos, I'll be referring to this mechanics stuff. I've seen a lot of international schools and teachers who do not emphasize this importance enough and then quickly move on to other topics and miserably fail students' lives. Now, let me give you an example why this mechanics stuff is so important. Now, for people who study a bit of physics would know in mechanics, power is defined as amount of work done per unit time. And work done, simply speaking, is the amount of transfer energy. So, and power is in watt. Whereas in electricity, we define power in a bit of a different way. You may have heard of P is equal to VI. So V stands for voltage and I stands for current. And in electricity, power is actually in watt, quantity-wise. So you may think, oh, there's two different formulas for the same thing, and physics is nonsense. Well, I'll talk more in detail about this bit, power bit in electricity here, but simply speaking, voltage is defined as amount of work done per unit charge as a charge flows through a certain amount of component, and current is defined as amount of charge flowing per unit time. So simply speaking, you can see the charge bit actually cancels out. And you can see that two things are essentially the same thing. So in electricity, power is defined as amount of work done, amount of transfer energy per unit time by a per charge as a charge flows through a certain component. So as you can see, electricity is actually all about mechanics of charges, whereas thermophysics is all about mechanics of particles and so on. So once you've fully mastered mechanics, you can quickly accelerate your learning speed for other modules because mechanics is also an area where the point three I emphasized, you always be given certain situations where you apply laws to explain certain things logically. So this point three is very vividly exercised on this topic called mechanics. So you can take this good practice and apply into other modules. And the fifth most important point is, do try to understand the laws or equations that you learn. 90% of the time, you see them, the derivations should make sense. Now, this may sound a bit contradictory to what I said at the beginning, that laws do not make sense. But apart from very fundamental laws like Newton's laws, other laws and equations and formulas such as Snell's laws, Doppler effect equation derivation should be fully appreciated because most of the physics questions you will encounter requires these skills to derive such equations, and if you cannot fully appreciate these derivations, then you have no such skills to solve most questions. You are only using these equations to touch on the surface. But having said this, understanding full derivation is perhaps the most painful job as a physics student, but there's also great satisfaction of learning once you've come to full understanding, and it's also linked to the idea that I mentioned that you should always try to question when you learn physics. So to summarize, I think these are the 5 most important points you should bear in mind when you study physics to score best marks. So first is, know where to question and accept. The most fundamental laws in physics cannot be fully understood, and you're only wasting your time to try to understand it. So watch out for the red boxes that I put. But apart from these red boxes, everything should be questionable and you should be willing to understand. And the second point is there's no such a thing as formulas or equations, but these are rather definitions. Now, this point is very important when you encounter long answer type of questions. Don't just try to plug in the numbers into these laws, but try to interpret them, which says about a certain relationship between variables. And the third point is in any physics explanations, it's always going to be in a style of you're going to be given a certain situations and you have to use these laws and principles and definitions, which I'm going to highlight in red boxes, to be able to explain certain things logically. This is a fundamental practice that you should exercise for every physics explanation you're making in any topics. Then physics should be sound fun. And fourthly, everything in physics is based on a topic called mechanics. So do master this topic and try to see other topics in physics as an application of this area. And lastly, do try to understand derivation of most laws or equations, apart from the very fundamental ones. Now, this is the attitude you should always have in physics to become a good physicist. So I think for the upcoming videos I'll upload, I'll be giving explanations on topics that you'll need to master in GCSE, MYP, IB, SAT, or AP Physics. I know that there are tons of YouTube videos out there that can already help you with this, but hopefully I'll give more clearer and better presentations so things are a bit more straightforward, and hopefully you can score better with my material. So again, if you're one of those students studying these, then please subscribe and leave comments, and thanks for watching.